Now, children, that we know that every chemical change is associated with a chemical reaction. So now we go on to the actual chapter and we have to study these chemical reactions and chemical equations. So here I have written down a chemical equation. I want you all to write down all the equations in your notebooks as they have been written here on the blackboard. And this will give you a practice how to write down the reactions and making equations out of them. Now, why do we need to convert a chemical reaction into a chemical equation? Because when we write down a chemical reaction, we generally write it in the form of words. It's called as a word reaction. Like here, one example is given to you. Aqueous solution of copper sulfate plus zinc dust, and an arrow, that is products are aqueous solution of zinc sulfate and copper. So this is called as a word equation. As you can see here, it's written. So this is a word equation. But if we have a number of reactants, here these are two reactants are there, that is copper sulfate and zinc. These two are reactants that are written on the left side. So we would have to write down so much if we have to write in words. And similarly here products, also you can see aqueous solution of zinc sulfate and copper. So a lot of time would go in writing down the reactions in words. So what do? We convert a word equation into a chemical equation. So how do we do this? So we make use of the symbols and molecular formulas of reactants and products. So by doing this, the time is saved and the things become more informative and they can be conveyed properly. So how do we convert a word equation into a chemical equation? So here we have to make use of the molecular formulas of reactants and products. So here what are our reactants? Our reactants are copper sulfate and zinc. So copper sulfate, this is your copper sulfate formula, CuSO4, and zinc, that is Zn. But how did we get this formula of CuSO4? So we need to know the valencies of copper and sulfate. This is sulfate radical, SO4. So Cu is having valency 2 plus and sulfate has valency 2 minus. So you have to just cross the valencies. When you cross the valencies, sulfate's valency goes to copper and copper's valency goes to sulfate. And therefore copper will get 2 from sulfate and sulfate will again get 2 from copper. But this is a whole radical, SO4. So we have to write it in bracket and then 2 outside. So this 2 and this 2 gets cancelled and you get the formula CuSO4. That is how we write down the CuSO4. Zinc molecular formula is Zn and you get zinc sulfate. So how do you get this zinc sulfate? So again zinc's valency is 2 plus, sulfate is 2 minus, crossing the valencies, zinc 2 and sulfate will get from zinc. Again we'll write it outside the bracket, these two will get cancelled. That is, you have to reduce it to the lowest term. Both will be cancelled and you get the formula ZnSO4. And what do other formula product is C. So this is how we can convert a word reaction into a chemical equation. So I hope you have at least followed something of this right now. It's just the beginning. Gradually, as you write down, you will understand more and more. So here we have two reactants. We have got two products. Reactants are always on the left side. Products are always on the right side. Reactants and products, they both are separated by an arrow which points to the direction of uh, the progress in the, it points to the direction of the progress of the reaction which is taking place. So it means that the reaction is progressing in this direction, that is formation of products. So let's go to the next slide. We will continue with the same equation that we were doing in the previous slide, that is copper sulfate and zinc. And here we have tried to write down more information about this equation. We have tried to make this equation more informative. So how can we make an equation more informative? So we have the reactants here, and we have written copper sulfate, and below here small bracket we have written AQ, that stands for aqueous. Aqueous means copper sulfate, which is a blue crystalline chemical, and we have dissolved it in water. So that is why it is written as AQ. Then we have taken metallic zinc. Then metallic zinc is solid, and therefore S we have written small s, and it is a silvery colored metal. And when they both react with one another, what are the products? So we have separated the reactants from the products by using an arrow which indicates the direction in which the reaction is progressing. So we get zinc sulfate, which is also aqueous, and copper metal, that is solid, and it comes out, it starts getting deposited, and in the beaker in which we carry out this reaction, it gets separated out, and that is copper, which is solid. Again we get some amount of heat. It's an exothermic reaction, so we write down heat on the product side. Heat is evolved, so that is heat is given out. This is how we can make the reaction more informative, by writing down the physical states of reactants and products. So what have we done? We have written the physical states of the reactants and the products. If there are more than one reactant or more than one product, how do we separate them? By making use of a plus sign. Now here what have I written? I have written down the names of the reactants and the product. So this is how the reaction is to be written, with the complete information about it. Then coming to the next one, that is second one, that is calcium carbonate is heated. Calcium carbonate formula CaCO3. How is the molecular formula made? Calcium valency 2, carbonate valency 2 minus. Again you cross the valencies, calcium will get carbonate's valency Ca2 we will write down, and CO3, that is a complete radical, so it will go in a bracket, and then valency of calcium is here reduced to the lowest term. 2 and 2 get cancelled, and you get the formula CaCO3. Similarly, the products are calcium oxide and carbon dioxide. You can indicate it with an upward arrow, or you can even write down a gas is evolved by writing a small g in a bracket. Calcium oxide is a solid, so you write down small s. Calcium carbonate is also solid, and we'll write down it as S. So what are you supposed to do here? You're going to heat. You're going to heat this. On heating, it decomposes to give you these two products. And how do we indicate heat? You can write down heat, or you can make a small triangle like this, which indicates that you have heated the substance. Here I have not written down the names of the products, and you can write down this is calcium oxide and this is carbon dioxide gas. So I hope you are following it, and let's go to the next slide. Third equation that we are doing is again it's a word equation that we have written here. Vegetable oil, it's liquid, so we write down small l, and hydrogen gas is passed G, and the temperature at which you carry out this reaction is 60 degrees Celsius in presence of nickel as catalyst. And what is your product? Vanaspati ghee, which is also called as dalda, and the state of this is solid. So how again we have made this reaction more informative? Vegetable oil, that is liquid, hydrogen, that is gas, then temperature at which it is carried out. All this information is written above and below the arrows. Temperature you can mention. Catalyst, you know what a catalyst is, the substance which speeds up the chemical reaction without interfering the reaction. So nickel is used as a catalyst, and you get vanaspati ghee, that is also solid. This is also called as hydrogenation of vegetable oil. Another one, Copper reacts with concentrated nitric acid to form reddish colored poisonous nitrogen dioxide gas. So what are the reactants? You can make out the reactants from here. Copper reacts with concentrated nitric acid. So copper is one, that is metallic, that is solid. Nitric acid, aqueous. Nitric acid, some formulas you need to remember. You do not have to go every time for crossing the valency. Some formulas you have to learn, like nitric acid is HNO3. Still the split is given here. Hydrogen 1 plus, this is nitrate ion, and NO3 1 minus. And what do you get? HNO3, that is nitric acid, because it's one positive, one negative. So we need not write anything, and we directly get the formula, that is HNO3. And what are the products? Products is copper nitrate, CuNO3 twice, aqueous plus nitrogen dioxide gas. Again, you have to remember this, and water. Again, you have to remember formula H2. So nitrogen dioxide is a gas, so we write down G. Names of the reactants and products are written here. States are written here, and formulas how they are made here. This is a new formula. So copper's valency is 2 plus, and this is nitrate. Just now we use this, so that is 1 minus. So copper will get nitrate's valency 1. We need not write. Copper is 2, so this is whole one radical here, NO3, and we will write down 2 outside. So we get a formula CuNO3 twice, that is 2. I have not balanced this equation. Balancing we learn in the next class. So till then, what you are going to do is you are going to write down these equations in your notebooks and practice them. Thank you.